Hi guys, how you doing?
Guten Tag.
What is it about today? Like, I'm exhausted. Tiring Tuesday. I think it's a thing, because it's like, I don't know what's wrong, but like I can hardly keep my eyes open. Like, I
even went to bed early last night.
I'm not that tired.
All
Alright.
Yeah, just totally skip today. Take a nap.
Okay. So today we are describing the transformations that we see on the parent functions. So we're looking at functions and asking ourselves, hey, what is the parent function, number one? And then number two, what are the transformations that would happen? Now, the nice thing is about all of these, we can double check on our calculators, make sure it sort of agrees with what we're thinking. But let's do a couple and see what happens here. There's definitely some I want to talk about for sure, like 2 and 4 and 9. There's definitely some real interesting ones going on here. All right, so right off the bat, we're going to, given each function, identify the parent function and the transformation. And it's very important that we write those transformations in the proper order, okay, so that they actually occur correctly. You know, I hate state testing. I absolutely hate it, because I'm one of those teachers who's like, I want to know what you're going to be testing on. Hey, Will, dude, can you get a little less comfortable for me? Thanks, man. And I'm one of those teachers who's like, I want to know what they're going to ask. So I go and I do like the practice test. Yeah. So in Arizona, I went to do the Arizona State math test for them. And then the very first question is not right. And I go around to all the other teachers and we're like, what do you get for this? And they're like, I didn't get that. And it makes me so mad, because they've got people like writing tests that aren't actually math teachers who wouldn't really know there's a right and a wrong, because they haven't done it before. Like, they just don't know. All right. And they're writing these test questions and I'm like, nope, that is totally wrong. And anyway, so it doesn't give me a whole lot of faith in state testing answers. So anyway, this is one of those things where it's easy to not get it in the right order, which is going to give you a completely different graph. Here on number 1, what is the parent graph? What is the parent function? Cubic, yeah. So y equals x cubed, or maybe we would write f of x equals x cubed, but that's our parent graph, so it's that cubic shape. And then what is this minus 4 going to do to that curve? Down 4. So then we just, transformations is just down 4. And that's the only transformation there. So this is what we're going to list for each thing here, just the parent function and the transformations. Yeah, except we don't have to do them. We just have to describe them. Okay, this is very interesting. So first of all, what is the parent function? Square root. Yeah, the square root of x. So that's our square root swoop. And so that's our parent curve. And then there's quite a lot of transformations happening here. So I'm going to start, this is 2 times our parent function. What does that 2 do to the graph? It multiplies the y coordinate. So my transformation for here, the first one, would multiply the y coordinate by 2. What is that called? Vertical stretch, yes. Vertical stretch by a factor of 2. So we can just put by 2. Vertical stretch by a factor of 2. Now, here we have a bunch of stuff inside the function. We have a negative inside that's inside with x. Does it affect things vertically or does it affect things horizontally? Horizontally. It's inside with the x, so it's affecting things horizontally. The x-axis is horizontal. All right, what does this negative do? It's a horizontal reflection, if you will. It's flipping it across the y-axis. I just like to write horizontal reflection You could maybe say over the y-axis. That's very specific, but I think horizontal reflection is great. It's just going straight horizontally the other way, okay? And so then, what is this x minus 1 doing to our curve? Right 1, yes. So then it gets shifted right 1 unit. All right, let's see if that makes sense. So we would take our curve, we'd stretch it tall, we'd flip it horizontally, and then we are going to shift it right 1. Okay? I just want to see if that's sort of what we're looking at here. So we have 2 radical negative x minus 1. Ooh, is that what we thought? Yeah, pretty good. You'll notice the gap here. Is it really a gap, or does it go all the way to the axis? It does go all the way. All right, our calculator just isn't quite that smart. So, all right, let's look at number 3 here. What is our parent function? Squared, a parabola, yeah, y equals something squared. So there's our power right there. So it's y equals x squared. It's a parabola shape, okay? And then we want our transformations. What should we look at first? The negative? Okay, what's that negative going to do? Is it a horizontal flip or is it a vertical flip? Vertical, yeah, it's a vertical reflection. It's on the outside of the function, so it's affecting the y values. It's going to flip them all, make them negative. Vertical reflection. You might say over the x-axis, but I like vertical reflection because, you know, positive x squared, negative x squared. That's a vertical reflection over the x-axis. Okay. And then what do we need to talk about? The 1/4, what? That's inside with x, so is it vertical or is it a horizontal change? Horizontal change. And what's it going to do to the graph? Does it compress or does it stretch it? Stretches it, yeah. So remember, everything with x is always stupid crazy. It's going to actually take those x coordinates and multiply them by 4. It flips the fraction, all right? If we take an x value and we multiply it by 4, it's getting bigger, right? So that's going to be a horizontal stretch. Horizontal stretch. Oh my God, I cannot write. TC8, horizontal stretch by 4, a factor of 4. All right, and then add 6, yep. Shift up 6, maybe. I could write shift up 6.
Do you think it would ever like get marked down by not saying by a factor of 4, or do we just say horizontal stretch by 4?
I mean, I think by 4 is fine. Anything like this, you would be like multiple choice, right? So if you saw add 4, you wouldn't choose that. You'd be times by 4, right? Like, okay.
Delta math is mean.
All right. Let's see. Number 4 here. What's our parent function?
Absolute.
Absolute value. Yeah. Y equals absolute value of x. Absolute value V shape. All right. And then our transformations. We have the stuff on the inside here. Inside with x. What is that stuff going to do? So do we shift it left 5 first? Or what does the 3 do?
Can I have Addie for a minute?
Yes, sir. What does the 3 do? Is it affecting the x's or the y's? It's inside with x, so yeah, it's going to affect the x's.
And this one's trippy because the 3 is in and out.
Yeah, it's true. It's inside the absolute value. So therefore, it's inside with x. And so again, everything with x is kind of crazy, it doesn't actually multiply the x values by 3, what's it going to do? It's 1/3 times the x value. It's actually taking those x values and dividing them by 3. It's shrinking them. And so this is a horizontal compression by 1/3. And then what does the x plus 5 do?
Doesn't it go left 5?
Left 5. Yep, left 5. And then what does the minus 2 do? Down 2. Yep, very good. Left 5 and then down 2. All right. All right. Super. Okay, let's see. Let's look at number 6 because this is kind of an interesting one. I'm going to write this in a slightly different way. I'm going to write it like 1/4 times 1/x, and then the plus 3. All right, what function is this? What parent function is this? Reciprocal function. Very, very good. Y equals 1/x. That's our reciprocal function. That's a crazy graph. That's the one that sort of looks like inverted L's. It's like gang signs. That's how I used to flashing math signs, right? Like this. Okay. Anyway, so there's a little inverted L shapes like that. All right. So now on the transformations, the reason I sort of pulled off this negative 1/4 is so that you could see, oh, here's my parent function, that 1/x. So what is this negative 1? Well, first, what's the negative going to do? It's a vertical reflection, so it's changing those y values to their opposite. So we have a vertical reflection over the x-axis, yep. And then, what does the 1/4 do to our function? Is it affecting things vertically or horizontally? Vertical, yep, it's on the outside of the function, so that's going to affect the y values. And what does it do to those y values? Yep, it's multiplying them by 1/4, so it's taking those y values and it's going to shrink them. All right, so this is a vertical compression by a factor of 1/4, or by 1/4. Vertical compression by a factor of 1/4, and then you can do up 3. Okay. Cool. What about number 8? What's going on with number 8? That's a weird one. Yeah, it has a double bracket. That's a weird one. Look, it says greatest integer function. Very good. So that was the double bracket with x. So that is the greatest integer function. Very good. That was the one that looks like stairs, right? A stair step function. Yeah. Yeah. So that's that one. That's that shape.
Wait, how do we get that
on your calculator? It's math. And so if I wanted to graph that one, I'd go to y equals, and then I would do the math menu, and then I was under num. If you arrow over to num, and then go down to int. So int is that function. So there's the greatest integer function. All right, and then, so I'm going to write this, again, a slightly different way because this looks a little bit weird. And so I have 1/2, and then I have x minus 5. So this is really 1/2 times the quantity x minus 5. So this is another way to write this. Do you see how they're related? Yeah, instead of dividing by 2, I can multiply by half, so that's the same thing. Okay, good. It's really important that when we have transformations in x, everything is factored. Like you'll notice this was not 3x plus 15. 3x plus 15, you would think it, compresses by 1/3 and then shifts 15. It doesn't do that though. So we have to look at it in a factored form, or that greatest common factor is pulled out. So that's why we're writing it this way. So it looks like that's all pulled outside. Pulled out that 1/2. All right, so what are our transformations? What's the 1/2 do? Does it compress or does it, remember everything with x is like stupid. It expands, yeah, it's 2 times the x coordinates. It flips and multiplies. So this, because we're doubling the x's, that's going to be a horizontal stretch by a factor of 2 because it's making those x's bigger. And then what does the -5 do? Right 5. And what does the -1 do? Down 1. Very good. Very good. You good so far? Good. All right, let's look at number, do we want to do number 10?
No.
No? We're good? All right, let's turn the page. See what's going on here. Okay, so we want to also be able to write some functions as well. Using a graph of each function, identify the parent function, then write an equation under for each transformation given. So when I look here at number 11, what's the parent function? What's the equation? Like what parent graph is shown? Absolute value of x. Yes, that is the graph shown. Absolute value of x. And if I want to translate this function 4 units to the right, so if I take this function and go 1, 2, 3, 4 units to the right, all right, here it is. So what's the equation for the green graph? Y equals x minus 4 inside the absolute values. Right, good job. So then the question is, hey, what do we write if I reflect in the x-axis? So I take this graph, and the original graph, and I reflect it over the x-axis. So now it's like this. And then I translate it 5 units up. So now I take this red curve and shift it up 1, 2, 3, 4, 5. So now it's like this. What is the equation of that red graph? And is the +5 on the inside or the outside? Outside. Good. So to reflect it across the x-axis, the negative goes on the outside. And then to shift it up 5, the 5 goes on the outside. So we don't have to graph it every time. We just have to write the functions. So this curve shown here, what's that parent function? The reciprocal function. Yep, y equals 1 over x. Okay. Now, I want to translate it 7 units down and 3 units left. So how do I need to adjust this function? So left, that'd be like x direction, yeah? So where should the 3 go? On the bottom with the x. Okay, so 1 over, and what should it be, x minus 3 or x plus 3? X plus 3, very good, very good. And now to shift it down 7 units, that's up and down, that's vertical. So we got to put this number outside, minus 7 on the outside. There we go. Does that make sense to you? Yeah? Could we check it with our calculators?
Yes.
Yeah? Okay. All right, so this one, we want a horizontal stretch by 3. 1/3. Very good, sir. So 1/3, we need a 1/3 with our x there. And it's going right 2 units. That also needs to be with the x. So left and right goes with the x as well. So, should we do, I'm sorry, this is looking weird. I forgot my 1 over. All right, there we go. 1/3. So, we need x minus or plus 2. What is it? X minus 2 or x plus 2? X minus 2. And I need to make sure that that is not, that 1/3 is not multiplied in. All right, y equals. All right, that's it. There's our 1/3, which we would flip, and that's going to stretch our x values by 3, and then we would shift it right 2. So that works. Cool. Let's see. Are you good? You think you're good for that? I think you're pretty good. I think you'll be fine with that. All right, cool. It is not a little